Hi students, let's look at this question which was taken from the year 2008 paper on question 9. It's modified by one of the school tutorial, I believe it's Hua Chong Institution. So it is given that fx is ax plus b over c plus d for non-zero constants. Okay, a, b, c, d are all non-zeros. And we are told, given that ab is not equals to c, ad is not minus bc not equals to 0, show that by differentiation the fx has no turning point. So what we need to do is actually just differentiate it as just like they ask us to do, right? So just differentiate it. So take fx. Okay, this is a quotient rule, right? So fx is equals to ax plus b over cx plus d. So this will be our u, this is our v. Then what we're going to do is just use quotient rule f prime x. Okay, then v square cx plus d square, v square. So you have v du dx, so it's v du dx, which is a, minus of u dv dx, which is c. Okay, that's that. Okay, that's a quotient rule. Then once this is done, we just need to simplify it, right? Okay, so we have acx plus ad minus acx minus bc. So be mindful of your manipulation here. Okay, that is very important. Then once at a, so what is left is actually ad minus bc is cx plus d squared. Now what we need to do is actually to show that no turning point just means that dy dx equals to 0 has no real solution, right? So this one just means dy dx cannot be 0. Okay, cannot be 0 because there's no point where it is there's no point where the gradient is 0 for it to turn, right? So that's that. So this case here we can see is actually since this is f prime x, right? So since ad, which is given by us, is not equal to 0, okay? So in other words, if I were to divide both sides by cx plus d square, this will be ad minus bc over cx plus d square cannot be equal to 0 as well. Then we know that this is our f prime x, right? So f prime x not equal to 0. So since f prime x is not equal to 0, hence fx has no turning point. Okay, that's that. I think the first part is quite okay. Then we look at the next part, part 2, which is a bit challenging, but I think it's pretty okay also. So what we can say, if ad equals to ad minus bc equals to 0, it just means that this over here, you look at this guy here, f prime fx can be 0. Okay, and in fact, it's always 0. That's the idea there. So for b, ad minus bc is 0, so ad equals to bc, and we know that essentially, or actually we know that f prime fx, this will mean that f prime fx is always 0. Okay, so what we can deduce is the gradient is always 0 for all real value of x. That's okay. Now the idea that gradient is always 0 for all real value of x is either is always what do you call it, is it's horizontal line, or it may be like, but the gradient is 0, right? Very likely it's a horizontal line. Okay, so the way you think about it is if we think about this is actually a rational function. You know that this is a rational function. So when we draw this rational function, it's either it looks like that or it looks like that. Okay, so I'm going to use Desmos. So at minimal, it looks like this, right? Okay, so if you can see, if I were to just swap the different values here, okay, so I could just, it will just change, right? So like that. Okay, so there's a point where when it morphs from one side to the other side, it becomes a horizontal line. Okay, so that's the idea of rational function. So it actually becomes a horizontal line. So this case here, when AD is equals to BC, it becomes a horizontal line. Then the next question is, what is the horizontal line? There are a few ways. One way which I will encourage students to do is just do a long division. Okay, because if you can find a horizontal asymptote and vertical asymptote, for the vertical asymptote, we know what is this vertical asymptote, right? This vertical asymptote is just x equals to minus d over c. But if we do the horizontal asymptote, we'll be able to see that when dy dx is 0 for all x real value, then we know what is the equation of the horizontal line. So I'm just going to quickly do a long division here. So what we get here is we just take ax plus b divided by cx plus d. So to get a coefficient of a here is not too bad. We just need to multiply by a over c, right? So this will be ax plus ad over c with b minus ad over c. So if you were to rewrite fx will just be equal to a over c plus b minus ad over c, cx plus d. Okay, then this is fx equals to ac plus cb minus ad, bc minus ab, bc minus ad over c, cx plus d. So you see this guy here, this appears again. So if when ad equals to bc, or ad minus bc is 0, this would also say that bc minus ad is 0. Okay, so essentially fx would just be equal to ac. Okay, or because ac, ad equals to bc, ac is also b over d. So you can rewrite this as or b over d. Okay, particularly this case here. That's that. So essentially what you can rewrite is the equation y equals fx is actually a horizontal line with the equation ac, y equals ac, or y equals to bd. I wrote wrongly here, so it's d over b, not b over d. Actually, it's correct. It's b over d. Okay, great. So that's for part B. So let's look at part C, part 3. Part 3 deduce this guy here, 3x minus 7, 2x plus 1. So what we can do is we just know that a is 3, b is minus 7, c is 2. So we just look at the coefficients here, right? Okay, and d is actually 1. Then we're just gonna compute it out. We just use part 1, so we just find dy dx and just show that it's always positive, right? So from here, from 1, we know that f prime fx will be ad, so it's 3 times 1 minus b negative 7 all the way by 2. Then this will be 2x plus 1 square. Okay, this is obviously, this is always positive. 14 plus 17, right? 14 plus 3, which is always positive since f prime x is always positive. There you go. So that's why 3x minus 7 over 2x plus 1 has positive gradient at all points. Okay, so if it's positive gradient at all points, you know that it cannot be this guy here because it's a rational function. It has to be this guy. Okay, so if you plot into a graph, you should be able to see how to plot it. It should be a positive gradient, right? So it is this guy here. Okay, then you can actually deduce, actually can just write down the horizontal asymptote and vertical asymptote and then just start drawing, right? So the horizontal asymptote, if you do a long division, it'll be just 3 over 2. You can just see these are just 3 divided by 2. It's quite fast. Then the vertical asymptote will be 2x plus 1 equals to 0. So x is equals to negative half, right? Correct. So this guy here. So we can start sketching. You can key in the GC, not an issue. Or you can just plot it out. Okay. So key in GC, just see how it looks like. So I draw the asymptote first. Then this is 3 over 2. Then what I can, you can just use GC, like I say, like just draw it out. So this is a rational function here. Okay. Then after which I'm gonna just draw the same thing here. I could just put when y is 0. You can just find where the intercept are. So when y is 0, then I know that it intercept at x 3x minus 7 equals 0. So x equals to 7 over 3. 7 over 3 will be here, a bit further away. So I think this, I'll just move this to a side. Okay, so it's about 7 over 3. Okay, then after which when x is 0, y is just negative 7, right? So I know this is way down below. Okay, roughly as such, maybe I just move this to move the axis aside. Okay, you don't really need to, you just draw roughly to scale. I think it's fine. So this is 7 over 3 comma 0, and this is 0 negative 7. Okay, so there's that. Okay, so this is how you do this question proficiently. If you have any questions, please do let us know, and I'll see you in the next question.